House Robber 3. So let's take a look at this to see what's the difference between this one and the previous House Robber problems. This is what? Okay, so there is an entrance of root. Two direct linked houses were broken into the same night. Then it will alert the police. Okay, this is the same condition. And it is a binary tree. Alright, so it's form a binary tree. Okay, example is, so basically the houses are arranged as a binary tree, and we cannot break into the house if it's a direct child. If we break into the parent house, then the children's house cannot be break into. Alright. Yeah, it's almost. I think the ideas are similar to previous questions. Let's do pick. Basically, if we break into a node, then we cannot break into this direct children. We can't break in. Okay, so if the node is null, then we just return, because we can't really break anything. And pick should also return a integer, which is the maximum amount. Return would be 0, because there is nothing. And now we can choose to break the house or not break the house. We can choose to break the house or not break the house. So first branch, let's say, hey, we break into the house, and we're gonna pick so if we break the house, then we cannot break into its left node, so it's no point to pass left node. So we're gonna pick node dot left dot left, and then pick node dot left dot right. So this is money. And also money plus equals to that. Alright, so this is fine. On the other hand, if node dot right is not empty, node, then we pretty much do the same thing, like right dot left and then right dot right. So we don't pick the direct children, but we pick the one below it. Pick self. Let's call it pick self to be more clear. And another one would be not peak self. Not peak self. In this case, it'll be 0 because we are not picking the current node. And similarly, not picking self. Not peak self will be, we should consider picking left and also picking right. So this can also be like we literally will pick left or pick right. Alright, so finally it's going to be a maximum of peak self and not peak self. Right. Okay, let's think about whether it's right or wrong. Okay, return, be returning the peak node, sorry, root in this case. Let's see whether it's correct or not. Not now. Okay, we pick the node or not pick the node, and then that'll be left and right. Seems to be correct. Okay, let's run it. Yeah, so those are correct. Okay, think about. It has a lot of nodes, which means it would actually be exceed time limitation. Might be. Yeah, let's submit it first to see. Okay, yeah. We need some way to cache the results. So, okay, what does it determine? We pass a node. Okay, alright. So let's make a cache for the according to each of the node, right? So pre-node, and then the value of that is going to be integer, denotes the maximum money it can get. Yeah, so we're gonna pass the hash map in integer cache. Right. So if it's now return, and then okay, all right. So if the cache already has that node, yeah, has that node, then return that cache directly. Okay, otherwise we're gonna calculate that, and we'll say and then we put that cache in, right, which is the node and max, right, cache dot put, yeah, and then we're gonna return the max in here. Yeah, and then here is just the cache. Run it again, it should work. Contains key, it's a typo in here. Oh, yeah, I forgot to pass the cache in each of the subsequent recursive calls. So cache, and here is another cache in here. So it should, yeah, this should be good now. Right, submit, and let's see. Okay, hooray!